Okay, let's start for solving the problem on video assignment problem 1. Problem 1 says Erin and her employer contribute $400 at the end of each month to her retirement account that earns 7% interest compounded monthly. When she retires after 45 years, she plans to make monthly withdrawal for 30 years. If her monthly account earns 5% interest compounded monthly, then when she retires, what is her maximum possible monthly withdrawal without running out of money? To have a solution for this problem, it means that she will going to have 45 years monthly ordinary annuity deposit for her retirement. So after 45 years, she is going to have 30 years withdrawal each month with 5%. So how many, for 30 years, how much should we withdraw every month? That is the problem. Okay. First, to solve the problem, we start with making the formula, that is making each payment every day, each period, means equal period, at the end of each period for 45 years means she's going to pay, she already contribute for her account with her employer for 45 each month payment. That means she will have, after 45 period, the amount she will withdraw for next 30 years for her retirement period. So the formula for the future value, that is she already accumulated for 45 years, will be, that is the present amount, that is she deposited each month at the end of each month, that is future value will be payment monthly times 1 plus I, that is the rate which is deposited in the account, minus to the power of total year or periods. I mean, she already deposited, minus 1 over the monthly interest rate. On this equation, we have already have the 45 years, which is going to be a year. Within a year there is 12 months, so the total period she will just deposit every month will be 45 times 12, which is going to be 500. That is, which we in the formula we use n, the total number of periods she has deposited. The payment will be 400 because her employer deposits every month, at the end of every month, $400. So PMT means payment every month will be 400. Okay, the other one is also the percentage. In the question, the account will be compounded in interest 7%. So 7% means 0.07. This one is for a year, for 12 months. So for each month it will be 0.07 divided by 12. That will mean the period interest, I, every month the interest. So according to the formula, we have PMT, that is the present amount which is deposited every month, and the rate every month, the rate of every month, and the total months, the total periods, that is n. That means 12 times the 45 years and 540. So we are going to just find the future value. How many cash it will be in the future after 45 years. So by substituting the numbers 1 plus the interest rate per month to the power of the total period, 450 minus 1 over each month's rate means 0.07 divided by 12. So this amount will give us about 22.1, something like that. So divided by each month's rate 0.7 divided by 12, it will give us 3 point, it will give us 3,792.54 something. So this amount, this digit will be multiplied with the amount they put every month, 400. So the total amount that is every month they put 400. So compoundedly, have interest with it. They got this 3,792.5 something like that. So we multiply with 400 each payment. It will be after 45, $1,517,037.85. So this can be rounded amount. It is 0.85 cents. So it will be in the full amount, $1,517,038. This is the amount she is going to have for her retirement period. Okay, so now during her retirement period after 35 years, she starts to withdraw every month. Okay, so for the withdrawal, there is also another formula, which for what year amount of for what total for 30 years, how much she can withdraw every month. We already know the amount she has already in her account. So this one for 30 years she is using plan for 30 years. So how much it will be every month she will withdraw. For this, there is a present value formula, which is already we have been taught. That is the ordinary annuity present value formula. That is going to be present value equals each payment with 1 minus 1 plus I to the power of the period she is going to withdraw. That is minus n, not positive n. This one, because she is going to take out every money each month, so she will drop down to the 0 after 30 years. So the power must be negative over each month's compound interest. The amount that she will withdraw with a different percentage rate. That is, when she accumulates, she is with 7%. Now she withdraw with a percentage of 5%. So 5% means for a year. So she is withdrawing every month. So every month she has a rate of 0.05 divided by 12. That is I. And the present value we already know, because she already accumulated that money for her withdrawal. So that amount is $1,507,038 or 37.85 or around $38. So PV, according to the form PV, the present value, it means already she has got the money, $1,517,038 equals her each payment, each withdrawal that is she's going to have, which is we don't know, and times 1 minus, this is the withdrawal, we must know this, plus 1 plus I to the power of n, negative n, not positive n, because she is going to withdraw and make the money 0 after 30 years over the each month's rate. Then if it will be in the formula, we will put for PV, for present value, $1,507,038 equals payment of her each payment for her withdrawal. It means it is a withdrawal for her account, which we don't know, and equals 1 minus 1 plus each month's interest to the power of negative 300. The 360, by the way, is for 30 years. 30 years means each month of 12 months, each year has 12 months, so 12 months times 30 years means 360 months. So the power will be negative 360. She is going to withdraw. So with that we made, and the rate will be 0.5 over 12, 1 plus 0.5 over 12, 1 minus, okay, and subtracting from 1 over the each month's rate, it will going to have about the point something 186.2816, something like that. This one, the one which is compounded. So, but we don't know the amount which she's going to withdraw. That times will give her the total amount she have got in her account, that the $1,517,030. So to get the payment of or the withdrawal of hers, we must take the present value, that is, you already have the money, 1 million, divided by the compounded rate, the compounded rate for withdrawal. So it is this one. When we divide that with the full amount by the rate, we will get the payment for her $8,143.79. This she's going to withdraw every month for her personal living. Okay, so it will be about $800-144 each month. That is the solution at first. Okay, because she only have $1,570,038. She will have for 30 years this one amount she got. She will withdraw only $8,144 amount every month for 30 years. Okay, this is the solution. Okay, if you have any question, I can answer for you. Thank you for now. Let's just run for the second problem.